everyone. Today I will introduce how to use the Facade survey module of LiDAR360 MLS to draw vertical sides. After launching the software, we first need to create a new project. Here, we can do so by adding the point cloud data calculated by live user BP directly. When drawing, we have the option to import panoramas to help. And that we can use auto roam in panorama images to preview the data conditions. After the data is imported, we can close the panoramic window temporarily when drawing. Because the current LiGrip devices do not have GNSS, data may be skewed. We can see that this side is on an incline if we cut a section. Thus, before drawing, the side should be set vertically first. The Set Vertical function in Facade Survey enables users to select points to fit a plane on two vertical sides of a building. Based on the angle between these two planes, the building is aligned vertically so that it is perpendicular to the horizontal plane. Because the building has only 3 floors, 3 planes can be selected evenly from top to bottom. If your building has 10 floors, selecting a surface every 1 or 2 floors from top to bottom is recommended to ensure that the selected surfaces are all on the same plane. This first side is Facade 1. After the first side has been selected, the current facade circle is generated, and it can be seen that it fits on the point cloud. After this, switch to Facade 2 in the Set Vertical window, and then select 3 fitting planes to generate a facade circle for Facade 2. Then, click Transform and a prompt will appear asking whether or not to confirm the transformation of the current project data and to overwrite the project. If Yes is selected, the original point cloud, panorama, and trajectory will be erased. If No is selected, the software will rewrite a project. It is generally recommended to choose No. Finally, open a new project. The new project has been converted into a new format, and we can view this vertical.ly.mmp file and after rotated.ly.data point cloud data in the file directory of the project. Under Profile, cut another section, and we can see that the previously tilted side has now been corrected. When drawing vertical sides, LiDAR360 MLS provides a variety of layers in which users can do so. Generally, it is recommended that we add the basic layers first, and a horizontal structure diagram is necessary to draw the base plane and vertical sides. When creating a new layer, be sure to pay attention to the shape of the layer. For example, if the window is on a surface layer, it should be a polygon layer. In contrast, the window frame should be a line layer. When drawing a baseline, we need to define a reference plane first. Depending on our needs, we can decide what plane position the reference line is drawn on and select it here, and/or adjust it upwards or downwards. We can also use the Pick Point Selection function under Tools to select a certain position drawn on the point cloud. For example, if the height is -3.247, enter -3.247 in POS, and it will round it off to 2 decimal points by default. After checking lock, the baseline drawn later on will be set there. The software provides tools to draw baselines by intersection and by perpendicular, and has a total number of 4 modes. The first mode, Baseline by Intersection, allows users to directly select points on each side from the point cloud, and then perform cross-plane drawing. This is a very accurate acquisition mode because the selected points are all on the point cloud, which makes it more consistent. The second mode is by using baseline by perpendicular, where users can select 2 points to establish the first side, and then drag and click, selecting one more point to establish the next side, which is perpendicular to the first, and continue until the frame is closed. In the third mode, uncheck Exact and click on Baseline by Intersection. The baseline will be drawn according to the default values in the top display. It is recommended to change the buffer in the Begin Quick Horizon section and adjust the buffer to 0.1 to reduce the thickness of the point cloud and results in a more precise drawing. This mode utilizes 2 points. Similarly, we can apply baseline by perpendicular, whereby the first side requires 2 points and the remaining sides require 1 point. Thus, there may be issues when drawing depending on the point cloud data, such like with this corner. All things considered, we can choose from various modes according to our drawing accuracy requirements. Now, after drawing the horizontal structure, we can use profile by line to draw several vertical surfaces according to how many sides the building has. Click to select the side intended to be drawn, and the user can switch between sides according to the baseline. Taking this side as an example, we first need to draw the outermost corner. By default, contours are drawn into the vertical layer. It is recommended to turn on the orthogonal limit function because after the data is set vertically, its outline, including various elements of the window, will be saved in relation to horizontal and vertical information. Use the Add Polygon function under Drawing to draw the outer contour. From here, click to establish the first point, and then click again to set the second point. We can see in the profile that this is an arc. Use the S key on the keyboard to switch the mode of drawing an arc. After adding the arc, continue to draw down until reaching the bottom. Continue to outline the bottom line with the existing baseline and then draw upwards when reaching the edge. After drawing upwards, we can see that there is another arc that needs to be added according to the shape of the top edge. So we click S again to draw another arc. Drag the cursor upwards to add the final vertical line and adjust it so that the line fits the top edge and complete the polygon drawing. When drawing windows, the software provides a variety of drawing methods. The first way is by using tectonic lines. Click on Add Tectonic Lines and left-click to add horizontal tectonic lines, and press and hold Ctrl left-click to add vertical tectonic lines. Remember to make sure the layer is selected correctly before labeling vectors. Once all the necessary lines are added, click on Mark Vectors and choose a window layer. If a line is misadded, we can right-click to undo it and then draw it again. When drawing, the panoramic window can help us to check whether our drawing is accurate or not. Sometimes, the ground objects scanned by the point cloud are blurry. For example, when a window edge cannot be seen clearly in the profile, but it can be seen more clearly in the panorama image, we can judge whether to draw this window edge based on the panorama. The second way is by using array. First, we need to draw the window frame as it is part of the whole window. In this figure, the windows are generally the same size and evenly spaced apart. Thus, despite spacing being a bit inconsistent, we can use the function of array to copy the window and the space around it. Frame the elements that need to be included within the array and press Enter to combine and copy them. Then, left-click to decide the starting point of the array. We can redraw the frame multiple times to correct the position, length, and width. Finally, click Enter again, and after the box turns green, we can drag to expand the array to the desired size. Double-click to complete the array. If windows are not arranged at equal intervals, we can use the Facade Move Rotate function to select and shift multiple objects using the keyboard to adjust up, down, left, or right. After adjusting, click Enter to complete the change. It can be seen that there are no windows here, but there are windows drawn. So we can delete the unnecessary windows directly with the box selection function. Also, these drawn windows don't fit very well here and should be adjusted. Click on the Facade Move Rotate function and highlight the windows that need to be adjusted. Then, click R on the keyboard for clockwise rotation and Q on the keyboard for counterclockwise rotation. The software has a default step size, but we can adjust it manually according to our situation needs. The Copy Vectors function allows us to copy the drawn elements to any position on the current side. Left-click and hold to select one or more elements to be copied, and click Enter to complete the selection. The copied selected elements will be highlighted. Move the copied elements to the new desired position using the mouse and left-click to paste. Left-click can be used to continue placing copied elements, and right-clicking can be used to exit the copy function. The software also provides some other drawing methods. For example, to draw the edge of a window can be done using Add Line. Because the orthogonal limit mode is turned on, only data in the horizontal and vertical directions can be drawn. If we need to draw a 5-meter line here, we can right-click to open the direction/distance and enter 5 in distance. This will extend the line length to 5 meters. When drawing a circle, it should be noted that the circle must be drawn in the surface layer. Click on Add Circle, which provides a 3-point circle method for drawing. Click on the desired position to add the circle, drag to adjust the size of the circle, and double-click to complete the drawing. To draw an arc, it must be drawn in a line layer. The arc function also uses a 3-point arc method, with the drawing process similar to that of Add Circle. Some complex structures may need to be drawn with multiple layers, and instead of using polygons to switch and draw arcs, we can draw elements separately in several different layers. However, when using Add Polygon, we can utilize the S key to switch the mode of drawing polygonal arcs, and it ensures that the elements are completely drawn. After all the elements of a side have been drawn, we can choose to export the data with Export DXF, which we can use on each edited side. Finally, we need to lay out all the sides in CAD to form a drawing, and then export the drawing. When exporting a DXF, we will be prompted to export baselines. Generally, the baseline only needs to be exported once. By default, it is placed in the project directory. We can use names such as East 1 or East Side A to name them, making them easier to distinguish. After the export is complete, the baseline will be generated following the first side. Now, I will open CAD to show the results of the exported data. We can choose to draw a building first and then export it, or we can choose to draw individual sides and export side by side. We can also export the current side as an orthophoto. Choose Orthophoto under Export and set the location of the newly exported data according to our needs. In the dialog box, we can also set the color bar and customize the resolution. After exporting, we can see the results of the orthophoto. The software also provides the functions to calculate area and length. If we want to know the area of the drawn window, right-click to open the attribute table of the window layer, and then click on Add Field. Under Name, enter Area, and under Type, enter Double, and click on OK. A new column named Area should appear in the attribute table. Select Area to highlight all rows, and right-click to choose Calculate Area. The area of each window object should be calculated after clicking. If we want to know the length of the window frame, we must first select the window frame layer. Here, our window frame layer is called Window Arrays. Similar to how we added a column for area, we can click Add Field and enter Length under Name and select Double under Type and click OK. Then, select the new Length column and right-click to choose Calculate Length. After clicking, the length of each window frame will be calculated. This may help us to judge how much paint the building needs and so to estimate the cost. Now let's discuss the Layers Manager in Appearance. Sometimes buildings may be relatively simple and so may require few feature layers to map the structure. If there are specific requirements when creating the layers for a map, such as line color and width, the Layers Manager can help with these sorts of configurations. For example, if this site needs to be colored blue, we can click on Layers Manager in Appearance, select the layer corresponding to the side, click on Color, select blue from the basic color options, and click OK. Note that the value of 2 under line width represents the second unit category of millimeter in CAD and doesn't mean 2 millimeters in CAD. When multiple users are working on the same project but assigned to different buildings, a set style can be exported to ensure consistency. To do so, one of the users can set the requirements or preferences in the Layers Manager and then export the configuration file, which will be an INI file. Then, the other users can copy the INI file so that the entire style of the project remains consistent. Also, double-check that everyone's appearance and measurement settings in CAD are the same as well. This concludes the video on how to use the Facade Survey module of LiDAR360 MLS to draw vertical sides. Thank you for watching!